Unit 6, lesson 5. We're on page 235. 235. Okay? So, guys, lesson 5 is a combination of 3 and 4. Okay? Because it says determining angles and sides in right triangles. The first, on lesson 3, we figured out missing sides using trig ratios. Yesterday, the second one, we found the angles. Remember the inverse sine, inverse cosine? Okay, so now it's a combination. So you just got to kind of approach the problem. What am I trying to find? And then figure out how to get it. So we do that here. In each case, calculate the measure of x to the nearest whole number. Okay, so to the nearest whole number for all of them. We have 4 problems here. So see, this one's an angle one. So whenever I see I'm finding an angle, you should have like a little light go off in here. Be like, I'm going to be doing inverse sine or cosine here. Okay, this one I'm finding a side. This one I'm finding a side. This one I'm finding an angle. Probably going to be inverse sine or cosine there. So the next thing you have to do is, what information do I have? So this angle, I have the opposite side and the adjacent side. So that means tan 12.7 over 5.2. Right? Opposite of adjacent, TOA. And all you have to do in your calculator is second tan of this fraction. And that will give you your degrees in x. Okay, somebody calculate that for me. 68. Okay, so x is 68 degrees. All right. So again, I'm going to keep pushing this because I do think it's important. Okay, it could save some of you guys on your test. Okay, 68 degrees, right? We know no matter what, we don't know what this is, but it's the longest, right? This is the middle. If this is 68, what's this?
So what type that is?
22, right? So we're going with 90?
Yeah.
22? So 22, does that make the smallest side?
Yeah.
Yeah. Yours made the one that's bigger, and then we know that's the biggest. So it makes sense. You feel good about your answer based on that. Okay, I'm just wanting you to understand, angles make sides. Okay, if I would have got, if I would have got 25 here, like, wait, I can't get 25 because that means this should be bigger. It's not. Okay, so make sure we understand the logical reasoning piece. Okay, so here, again, looks like we're doing kind of a tangent today a bit. Opposite over adjacent. So we have tan on this one. I'll do it up here. So tan of 24 equals x over 68. And so we just times 68 to both sides for our answer. So 68 times tan 24 is x. X equals, what do we get this time?
We are confused on what you did. 68 times 24. You do 68 times.
Yes, 68, and then the calculator automatically times them, but you can put multiplication between if you want.
Wait, so...
How do I get that?
No, like, how do you...
Punch it in.
Yeah.
So you punch it in, you go 68. Literally, you can just hit tan right now, and then that means multiplication because they're next to each other. And then just put 24, yeah.
Oh,
Okay, what'd you get, Travis?
30.
30 for this one? Okay, so let's see if that makes sense. So if this is 24, it makes the smallest side. 30 is smaller than 68, which is the medium side, so we feel good. Okay, the hypotenuse would be bigger than 68. Okay, all right, so then this one, we got angle. They gave us 2 angles. Oh, the 126. So we have opposite over hypotenuse. Sine. So good. So we're going sine of 69, 126 over x. Again, I feel like the only way to describe it's a trick. Remember, that little quick step you can do is that these switch spots. Okay, sine 69 goes underneath, x goes here. Okay. So therefore, what is x there? 135. And that makes sense because it's bigger. It's the biggest side. Okay, we do anything too fast? We doing okay? All right. And we're finding angle again, and we have adjacent and hypotenuse. AH, cosine. Cos of x equals 4 over 7.2. Inverse cos to both sides. There you are. Okay. And what's that one? 56. 56 degrees. Perfect.
How do you know whether you use the inverse or like the...
Well, so inverse we use to find angles because the inverse step, Logan, is, see right here, I'm trying to get x by itself. To get rid of the cosine, I have to do the opposite, which is the inverse. So I opposite both sides, and the x is now alone, and then I'm good to go.
That's just to find angles?
So yeah, when you're finding angles, that's when you're going to use inverse the most. Okay. Any other questions? Okay. All right, a telephone pole is 11 meters high and supported by a wire 13 meters long, fixed to the top of the pole to the ground. Calculate the nearest degree, the angle between the wire and the ground. Okay, so we have telephone pole 11 meters high, so we'll draw that. It's 11. We have is supported by a wire 13 meters long, fixed to the top of the pole. So it's a ton of the top, and it goes like this. Okay, and it's just staked into the ground. Okay, and it says that's 13 meters long. Calculate nearest degree, the angle between the wire and the ground. So we're trying to figure out this angle here. Is everybody comfortable with that picture?
Is that a right angle?
Yeah, well, the left side will be a right angle, yeah, because we're assuming that the pole is straight up and down, not crooked. Okay, so now that means we're trying to find this. So we want opposite or hypotenuse. So sine of x degrees is 11 over 13. So log, we'd be doing inverse here. So there it is. Okay, and what do we get for that? 58 again, okay. Calculate the distance to the nearest 0.1 meter between the point where the wire is fixed to the ground and the foot of the pole using. So we're trying to find here, this distance. So we can use Pythagorean theorem and we can use trigonometry. So we can use Pythagorean theorem would be 13 squared minus 11 squared equals the ground squared, whatever, g, or you can put x there, doesn't matter. So it's going to be 169 minus 121. So it's going to be 48. And then you square root, it's going to be almost 7. So the ground is about 6.9 or something. So then you can just see, I mean, I think Pythagorean theorem might be a little bit longer. Might be easier, but it's a little bit longer. Trigonometry, if you know it, it's probably easiest. So if we want to figure out what this side is, we know what this degree is, so we can use that degree of 58. So I would probably go with, for me, I would go cosine. And does anybody know why I'd go cosine? I go cosine because then I don't have to worry about any weird flips, because cos of 58 is going to be my x, like this side here, over 13. And so I have that easy multiplied by 13 move. Okay, if I would have done, let's see here, for this side here, if I would have done tangent, it would have been opposite over adjacent. I would have my variable in the bottom. Okay, you can still do it. I just think that's a little easier because simply all I have to do is 13 times cos 58 is what x is. Okay, and that should be 6.9 something. Somebody want to confirm that? 6.9? Okay. So you can use cos there. Okay, questions, concerns? Okay. Let's go ahead and try the last piece here. Solving right triangle. So solving right triangle means that we have to determine the length of each side, the measure of each angle, in addition to the right angles. This is what I was talking about. We can, if you're given a little bit of information, you can find the rest, and we're going to do that. Okay. So solve for the given triangle. Give all answers to the correct nearest whole number. So here we go. We're going to use everything we've learned to get this down. So we're given that angle and that side. So first off, I can find all the angles easily because 90 plus 37 plus this should be 180. So I'm going to go 90 plus 30, that's 127. 180 minus 127 is 53. This angle here is 53. Has to be. By definition of a triangle being 180 degrees. So you need to remember that. If I'll make a little note on the side there. Whenever you have two angles, you can find the third every time. People always forget that. Like, oh, I can't do that. I have this angle. Yeah, you do. Okay? So you have that. So we have all our angles. So let's list these, and that's how you list them. Okay? Yesterday we talked about this, maybe in the second class, not you guys, but you can list it BAC or just angle A. Okay? For being easier, we can just go angle A is 37. Angle B is 90. Angle C is 53. And how that changes, like I said, remember, it also could be, this could also be CAB. This one could be ACB. Oops, no, that one's, sorry. That's angle B, so that could be CBA or ABC, yeah, doesn't matter. And this one could be the one I said, BCA. Doesn't matter, but the difference is the only thing that happens here, this guy in the middle is where the angle's at. It's just giving you 3 points to determine an angle. Don't be confused by that. Okay, so now we have to use trig to find the two missing sides. So we have hypotenuse. So I'm going to use, if we have hypotenuse, then which one are we going to have to use for both of them? Sine and cosine, because sine and cosine is so and cos, so that's the only one that have h in it. Okay, so we're going to use sine. So we're going to do, doesn't matter which angle, I'll do the 37 here. So BC, sine of 37 equals BC over 33. So you're going to times 33 to sine of 37 to get BC. Going to do the same thing for cosine. Cos of 37 for AB. And then you get 33 times cos 37 equals AB. Okay, so what are those? What's the BC? Somebody get that on the calculators, let me know. What's that? This one's 20. Okay. BC is 20. And I expect another one to be bigger than 20. 26. Okay. So we have all of our stuff. 20, 26, and 33. Okay. All right, last one here. Solve the triangle DEF. Give all the sides to the correct nearest tenth and all angles to the correct nearest whole number. I'm going to pause this one. I want you to try this on your own, and then we'll go from there. All right. So, Travis, which one? Like, where did you start first? Where'd you go with your first direction? Oh, doing Pythagorean? Yeah. Okay, so he did Pythagorean, get the hypotenuse. Perfect. So he went, and guys, there's a billion ways you can do this. Just hopefully you have that same answer. Okay, and then what did you get there? square root, and that's like 7.1 or 2? 7.2. Okay, so 7.2 is his hypotenuse. Good. Okay. We'll stay with you, Travis, since you had your own track. What'd you do next?
Then I did angle F.
Okay.
I did opposite over adjacent
Tan. Okay, so you did tan of angle F equals 5.3 over 4.9. Okay, good. Mm-hmm. Okay. Okay, good. And so we got 47 here. Doesn't have to do any more trig ratios because he knows that the next one's going to be what? 43. You don't have to do sine or cosine because remember, all those are there for you. Once you have 2, you can find the third. Okay? Perfect.